Let's look at the large language model settings and roles. In the OpenAI playground, you probably have noticed there are multiple key parameters that you can adjust. So these parameters can control the behavior of our large language model. You can tweak these parameters to get exactly the kind of output you want, whether that is something highly creative, highly accurate, or somewhere in between. Let's start with temperature. Think of temperature as a control for how spread out the model's guesses are. At a low temperature like 0.1, the model tightens its focus, making the probability distribution steep. This means it strongly favors the most likely word or phrase, leading to very predictable, accurate outputs. But as you increase the temperature, the distribution flattens out, allowing the model to consider a wider range of possibilities. This makes the output more creative and varied, but also more random. It's like turning up the heat and watching the model explore less obvious options. The next parameter, top P, this one is a little bit like filtering. Imagine you've got a list of all possible next words, each with a certain probability. Top P decides how much of this list the model considers. For example, when top P is set to 1, the model considers all possible words it could use next. If the top P is 0.9, that means the model will only consider the top 90% of the probability distribution and effectively ignoring the least likely options. Can you guess what happens if we set top P to be something very low, like 0.1? Yes, the model would pick from only the very top choices, making it more predictable. Max length is pretty straightforward. It controls how long the output can be. If you are generating a short summary, you might set a low max length to keep it concise. On the other hand, if you're asking for a longer length, the model will keep picking words from the distribution until it hits the limit. This may lead to more diverse output, but if you ask for too much, the model might start to ramble or lose coherence. So finding the right balance is the key. Stop sequence. This parameter is like a stop sign for the model. You can set specific sequences of words that, when generated, will stop the model from continuing. For example, if you're generating a list, you might use a period or a new line as a stop sign to prevent the model from adding unnecessary details. This is super helpful when you want to control the length or content of the output. Imagine if you are writing a formal letter and you want it to end politely, you could set sincerely as a stop sign to ensure it wraps up at this word. Frequency penalty. This setting controls how much the model penalizes itself for repeating the same word or phrase. If you set a high frequency penalty, the model will try to avoid repetition, which can be great for making the output more varied and interesting. But if the penalty is too high, it might struggle to use necessary terms multiple times, which could lead to awkward phrasing. What do you think would happen if we set the frequency penalty too low? Yes, the model might start repeating itself too much, leading to redundant output. The last parameter is presence penalty. This is a little like frequency penalty, but focus more on encouraging the model to introduce new ideas and new concepts. A high presence penalty pushes the model to explore different topics, which can be useful for creative tasks. But as with frequency penalty, too much presence penalty could make the output less coherent, as the model might go too far from the main topic. It's like encouraging someone to brainstorm, but not letting them settle on any one idea for too long. To wrap it all up, all of these parameters are your toolkit for guiding the model to produce the kind of output you need. Whether you're looking for creativity, accuracy, or a balance of the both, understanding and adjusting these parameters can help you get the perfect response from the model. So next time when you are working with an LLM, don't forget to play with these settings and see how they can change the way the model thinks and responds. The last topic I would like to introduce is the system-level prompts versus user-level prompts. The system-level prompt sets the stage for what you can do next. These prompts define the boundaries and capabilities of the system interaction. Why is system-level prompt useful? It is like the rules of a board game. So system-level prompts is like setting up the rules and make it clear what your options are. Now let's think about the user-level prompts. This is your part of the conversation. You provide specific input and request specific output. It is like choosing your move in the game based on the rules provided. Why is it crucial to differentiate these two roles? The purpose is to avoid confusion and ensure a smooth interaction.